Let's start with section 2.5, transformation of functions. We have two types of transformation. We have the vertical transformation, which is the outside techniques, and we have the horizontal transformation, which is the inside technique. So here is the first thing. We're going to start from the vertical. If you have the parent function, let's go back before we moving on. We have how many types of the parent functions? I'm going to write down these here. If you remember that, we have this parent function. The first one, we have f of x equal x, and we have f of x equal x squared, and we have the third one, f of x equal x cubed, and we have f of x equal number 4. We have f of x equal square root of x. 5, we have f of x equal the cubic root of x. And number 6, we have f of x equal 1 over x. And we have f of x equal the absolute value of x. And last one, we have f of x equal, it's just a linear plus ax plus b, or mx plus b, because this is the slope. So you can type it mx plus b. So we're going to use these basic function or parent function to do the transformation. So if you have f of x plus a, is going to be shift up. If f of x minus a is going to be shift down. If there is a negative sign outside the basic function, is going to be reflect over x-axis. If you have a number outside the basic function, is going to be stretched by a. And how are you going to find the stretch? Just go ahead, pick 2 points and find the slope. If you have 1 over a f of x, is going to be shrink by a. How to find the shrink, how to find the a, just go ahead and find the slope. So let's do some examples of the vertical techniques. Then we're gonna go back and do the vertical techniques, and then we're gonna go back do the horizontal techniques. So for the vertical techniques, here's an example. If you have f of x equal the x squared plus 5. So you see here is the basic function. This is the basic function, and it's shifted plus 5. So it's going to be shifted up. So the technique is going to be shift up. Here's another example. If you have f of x equal square root of x minus 3. So this is the basic function. Minus 3 is outside. So it's going to be shift down. Here's another example. If you have a number outside, if you have a number outside, for example, if you have f of x equal 3, let's do absolute value of x. Here is a number outside. So this is like number 4. It's going to be stretched by a, which is number 3. Now, if you have like number 3, if you have a negative sign, like negative cubic root of x, that means it's going to be reflect over x-axis. Let's do another example. If you have f of x 1 over 2, let's say x squared or x cubed. 1 over a outside the basic function is look like number 5. 1 over a outside the basic function. So in this case, going to be shrink by not 1 over a, not by 1 over 2, shrink by a. A is the number here, which is 2. So shrink by 2. That's it. These just examples about how you're going to figure out which type of techniques if the number of the sign is outside the basic function. Like number outside here's the basic functions. So that's mean, you see, this is the basic function. So in this case, here is the basic function. This is the basic function. This is the basic function. This is the basic function. So the technique is outside. So it's going to be vertical technique, shift up, down, reflect over x-axis, stretch by a vertical stretch. You're going to stretch the function like vertically. Shrink, you're going to shrink the function vertically. We're going to do an example. So let's go to the next technique. Then we're going to add these together before we move into the examples. So the next techniques, the next one is the horizontal techniques. So horizontal techniques, that means inside. That means the change is going to be inside. So if you have f to the x plus a, that means the number inside the basic function. So it's going to be shift left. Be careful. If it's a plus, shift left. F to the x minus a is going to be shift right. If the negative sign inside the basic function is going to be reflect over y-axis, not x-axis. If f ax, a inside the basic function, so it's going to be shrink by a. F1 over ax is going to be stretch by a. So let's do some examples so you can figure out these, and then we're going to add these two techniques together because you can get more than one technique on the same time. So let's check here. Let's do example 1. If you have f of x equal square root of x plus 3. So if you look, where is the basic function? The basic function here, this is the basic function on the number inside the root. That means this is inside technique or horizontal technique. So it's going to be shift left. Shift left. Here's another one. If you have f of x equal x minus 3 squared. The basic function is x squared. This is the basic function x squared. That means the number inside, so it's going to be shift right. Shift right or shift to the right. Let's do another example. If you have f of x equal, let's do square root of negative x. The negative sign inside the under the root, which is the basic function is the square root of x, but there is negative sign under the root, so it's going to be reflect over y-axis. And here's another example. If you have a number inside, for example, like the absolute value of 3x, the number is inside, is going to be shrink. It's going to be horizontal shrink. That means you're going to press on the vertical on the function from both sides, on the graph from horizontally on both sides to shrink it. So it's going to be vertical horizontal shrink. So it's going to be shrink by a, which is 3, but we have to mention it's a vertical shrink or horizontal shrink. So this is horizontal shrink. Remember inside, so it's going to be shrink by a, but it's horizontal shrink by a. And here's another one. If you have f of x equal, let's do 1 over 2 x squared. In this case, is going to be stretch because 1 over 2 inside the x squared, inside the square. So it's going to be horizontal stretch by A, which is 2. So here's another 5 examples just to show you that. Then I'm going to merge these. But before we doing more examples, let's go to website and check this example. So here on this one, you have match each function h with the transformation. So let's check that. H of x equal f of x, which is the basic function, plus c. So if it's a plus c, that means we have outside technique because the number is outside. So it's similar to this one. That means we're going to choose it's shifted up. So it's going to be a vertical shift, c units down. No, it's a vertical shift of f c units up. Let's check the second one. The second one, h of x equal f of x minus c. So it's going to be shift down. So it's going to be vertical shift c units down. Let's go to the next one. Next example. H of x equal fx plus c. You see the technique is inside, which is a plus, so it's going to be shift left. So it's going to be horizontal shift c units to the left. If it's minus, it's going to be shift right. So it's going to be horizontal shift c units to the right. That's it for this example. Now let's do examples. We're going to mix these two techniques together. So now if you have f of x equal, let's say 3x squared minus 5. We just need to write down the technique. So check, I'm going to start from the left to the right. If I have number, and here's my basic function, so I have to locate the basic function. If I have a number outside the basic function, that means it's going to be a number outside stretch by A. So the first technique here is going to be vertical stretch. Vertical stretch by 3. You have to mention which type of stretch, vertical or horizontal. Then minus 5, that's mean outside, so it's going to be shift down. You can mention vertical shift down. How many units? 5 units. That's it for this example. Let's do another one. If you have f of x equal negative 6, x, let's say square root of x, negative 6 square root of x plus 7. How many techniques do we have here? Let's start from the left to the right. The first technique, here's my basic function. Negative 6 outside, negative 6 outside, so it's going to be reflect over x-axis. Then 6 also it's outside, so it's going to be stretch by A. So it's vertical stretch, mention the type of the stretch. It's a vertical stretch by 6. Last technique, plus 7, which is outside the basic function, so it's going to be shift up 7 units. So we have 3 techniques on this one. That's it for this example. Let's keep going and do more examples. Now, what about if we have this one? F of x equal negative 2 square root of x plus 3 minus 4. Let's check how many techniques do we have on this one. There's negative sign, and here's the basic function. Always locate the basic function. There is negative sign outside the basic function. That means is going to be reflect over x-axis. Now the second technique, there is 2 outside the basic function. So it's going to be vertical stretch by 2. Next technique, plus 3 inside the basic function, inside the root. So this one, if it's a plus, is going to be horizontal or shifted to the left. So if you say shift left, that means horizontal technique. So shift left 3 units. Last technique, minus 4, which is outside. So it's going to be shift down. How many units? 4 units. 4 units. That's it for this one. Let's do another example to write down the techniques. If we have f of x equal negative 1 over 3 x minus 4, let's do squared, plus 6. The same thing from left to the right, negative sign outside. This is the basic function x squared. So it's going to be reflect over x-axis. The second technique, 1 over 3 outside the basic function. So it's going to be vertical shrink by 3. Next technique, minus 4 inside the basic function. So it's going to be shift right. How many units? 4 units. Next technique, plus 6, which is outside technique. So it's going to be shift up 6 units. That's it for this example. Here's another example. If you have f of x equal, let's say negative 1 over 2 x plus 5. Negative sign outside, that's mean reflect over x-axis. One over 2 inside the absolute value, because my basic function is the absolute value. So now it's horizontal. Horizontal. If it's 1 over 2, let's go back to this page. So you have to be careful. If it's 1 over 2, inside is stretched by a. It's a horizontal stretch. That's mean this one is going to be horizontal stretch by 2. Next technique, plus 5, which is outside. So it's going to be shift up 5 units. That's it for this example. Let's do one more. If you have f of x equal square root of negative x plus 5. Let's do it plus 7. That's mean Negative sign inside the basic function. So now it's reflect over y-axis. Second technique, +7 is going to be shift up 7 units. That's it for this example. So next example, example 5, then we're going to go back to example 3. Example 5, what they ask you to do is we have used the graph of f of x equal x squared. So we already have, they're telling you this is your basic function, which is here is the graph. But we have, there is a techniques they added to this graph. The techniques, if you look to the basic graph, is graphing here. How are we gonna graph the basic function? Let's do it here on the side. We're gonna create a simple table to graph the basic function. So the basic function pick to graph f of x equal x squared. We're gonna just put this table, small table, x, y. The domain for the x squared, if you check, if you go back to the previous section, I gave you the domain and the range. For x squared, the domain and the range is negative infinity to positive infinity. That means I can choose negative number and positive number with the 0. So these 3 points is going to be enough to graph the basic function. -2, plug in -2 here, -2 squared, that means -2 times -2 is going to be 4. Plug in 0 here. It's -2 squared. That means equal 4. So the first point is -2 and 4. Plug in the 0, 0 squared. That means going to be 0. The second point is 0, 0. Plug in 2 here. So it's going to be 2 squared, which is equal 4. So the third point is going to be 2, 4. So now let's graph these points to get the graph of the basic function. So the first point is 0, 0 here. And if you look to the second point, -2, 4. -2, 4. Here's the second point. So here is -2 and 4 here. You see, this is the graph of this function. So it looks like -2 and 4. The graph is supposed to be like this. Let's do it better than this. Like this. And this other point is 2, 4. Here's 2 and here's 4. That's mean here. But check what happened. This is the graph of the basic function for the x squared. And if you look what happened to the graph is moved down. The graph moved down. How many units? 1, 2, because here is the basic point. We're going to depend on this one, and it shifted down 1, 2. That means to write down this function, we're going to say it's f of x. Here is the basic function, and add the transformation, shifted down. How many units? 2 units is shifted down. That's mean we're going to say -2. So this is the new graph. You can say y, you can say x, it doesn't matter. So we're going to type here x squared -2. This is for this new graph. Let's go to the next one. The next graph is going to be different. It's the same thing, the basic function, which is the same these points, because x squared. So the first point is -2. That's mean our graph like this. And 0, 0, and then going up. The other side is supposed to be going to the 0, 0, and 2, 4 is here. Here's the 2, 4. The graph going up from here, and the graph going up from here. So this is the graph of the basic function. Now let's check what happened to the new graph. Let's fix this side. What happened to the new graph? Goes here the point and keep going down like this. The graph, the first thing is reflect over x-axis. So reflect over x-axis, that mean is going to be like this. You're going to move these two sides down. So it's going to be like this. Reflect over x-axis. Now this one is similar to this graph. So the first thing, if it's reflect over x-axis, that means I'm going to say f of x equal, here's the basic function. If it's reflect over x-axis, I have to add negative sign outside. So before I'm doing that, I'm going to write down my basic function like this. In case if there is a technique inside. If it's not, I'm just going to write down x squared like the previous one. So let's check the next step. The next step is the graph shifted to the, you see this is the basic point? Shifted 1, 2. Shifted here. Shifted 2 units to the left. 2 units to the left. That means the new location is going to be here. So here's our new location. The graph is shifted to the left. So that means I have to add 2 units. So add 2 units inside because it's a horizontal technique. Then the graph is shifted up. How many units? 4 units. So if it's shifted up 4 units, that means I'm going to add 4 units outside. So this is our new graph. I'm going to erase everything. And you're just going to locate here. You don't have to do all these graphs. The basic function, it's here. Then it's reflect. So a negative sign outside, shifted to the left here. This point is shifted here. 2 units, that's mean inside. So we're going to add because it's to the left, then shifted up here. So you're going to add 4 units outside. So that's it for this example. So we're going to type here y equal negative 2 parentheses, negative 2 parentheses. Inside these 2 parentheses is going to be x plus 2. Do not forget the squared. And go down is going to be plus 4. Let's check that. That's it for this example. What's wrong with this one? It says shifted down. So for this one, it shifted down not 2 units, it shifted down 1 unit. So I have to fix this one. I did mistakes. So be careful with the numbers. This is 1, and here's the 2. So this one is going to be shifted down by 1. Here we go. Let's do the same thing with example 6. We're going to do exactly the same thing. So example 6, it says, do the same thing. We have to write down the function for this one. So if you look to this graph, they already give you the basic function, which is here. So now we already know that our basic function f of x equal x cubed. The graph of the x cubed, this side is up and this side is down. So up like this, curved, and down like a curved. But you have to know the graph of the basic function. So now let's check. The basic function on this one is shifted up 2 units because I'm looking to the origin point. The origin point, this one is up and this one is down. The origin point is shifted 1, 2. So 2 units up. That's mean our new graph is going to be f of x equal x cubed, shift up 2 units, so plus 2. So I'm going to just say here, it's x cubed plus 2. Next one, we're going to do to the next graph, go to the next graph. Now it's different. If you look to the graph of the x squared is going to be like this. This shift up and this shift is down. So what happened to the new graph? It's reflect. So you have two types of reflection. If you reflect over x, that means this side goes down and this side goes up. So we can do that. It's reflect over x-axis. That's mean if I do the reflection over x-axis, here's the x cubed. I'm going to open parentheses, x cubed, reflection over x-axis. Then I'm going to check. If I do the reflection over x-axis, that means this side is going to be goes down. So I'm going to go down like this. And this side is going to go up like this. Because I'm doing reflection over x-axis. This side goes down and this side goes up. Now this one's similar to this graph. It's exactly the same thing, but it's shifted. I'm going to look to the original point. Shifted to the left. Let's check how many units. This is 1. And here's 2. I'm going to look to the original point. Don't confuse yourself. We're going to go to the graph. So this is 1 unit to the left, which is here, the original point. So it's going to be shift 1 unit to the left. That's mean inside, I'm going to say x plus 1. 1 unit to the left. Then it shifted down how many units? 2 units down. So in this case, it's going to be minus 2 down. So this is our new graph. That means our new function is going to be negative. It's going to be negative, open parentheses. It's going to be x plus 1 inside the parentheses. I'm not writing down anything. 2 parentheses. It's going to be x plus 1. And don't forget the cube. And then outside is going to be minus 2. So here's the graph of this function. Let's keep going to the next one. The next graph is going to be, they already give you the graph. The basic function is the absolute value of x. So what I'm going to do, f of x is the absolute value of x. I already know from the previous section, the graph of this function is like the v. Like v. So the graph of the basic function here does look like this. Now let's check what happened to the new graph. So my basic function is, I'm going to write down, put down 2 line, the absolute value, and let's write down the technique. The first thing, if you look to the new graph, is like this. That means it's reflect over x-axis. That means this graph, this side goes down and this side goes down. So in this case, this is the graph reflect over x-axis. Here's our new graph like this. Then shifted to the left, how many units? So first of all, let me write down the technique for reflect over x-axis. That means negative sign outside. Then shifted to the Left, how many units? This is the 1, this is -2, this is -3. That means 3 units to the left. So in this case, I'm gonna add a 3 to the left. This doesn't shift down, so that's mean we just have to write down the negative sign. Here is the absolute value. Let's check where is. Go to the functions, and here's the absolute value. So you're gonna go to the functions. Here's the x, and you're gonna say +3. That's it for this one. Let's go to the next one. So the basic function, the graph of the basic function, we already know it's here. If you want to learn how to graph it, let's check how to graph the basic function. Because you can do the same thing here, you can do the same thing here, like these examples. The domain for the basic function is from -infinity to +infinity. So to graph the basic function before we add in the technique, you're gonna choose x. That means I can choose also -2, 0, 2, because negative numbers and positive numbers. The absolute value of -2 is going to be 2. The absolute value of 0 is going to be 0. The absolute value of 2 is going to be 2. That means to graph the basic function, I can graph these points. Then we're going to add the technique on it. So let's graph the basic function. If you see, the first point is -2, 2 here. The second point, 0, 0, and 2, 2. That means the basic function is going to be like this. This is the basic function. Now let's check what happened to the graph. The graph is shifted down. Here's the basic point, shifted down until this point. That means it's outside technique. So here is the absolute value. Here is the x, shifted down. How many units? 5 units. So -5. Then shifted to the right 1 unit, because here is the 1. So 1 unit. So that's mean to the right, so -1. So that's it for this example. So we're gonna write down here, let's erase this one. To the functions, the absolute value is going to be x -1, and outside the absolute value is going to be -5. Let's check this example. That's it. So here is our new function. The same thing, how to graph the basic function for this one. If you want to graph the basic function for f of x equal square root of x, the domain for this function is from 0 to infinity. Bracket, the 0 include. So to graph it, that means I can't choose negative. I can't choose negative numbers. I have to choose only positive numbers. From 0, I'm going to choose 4. That's enough to graph this function. You can choose 16. So plug in 0 here is going to be 0. Plug in 4, square root of 4 is going to be 2. Plug in 16 here is going to be 4. So to graph the basic function, we can graph these points. Let's graph these points. Here is 0, 0. We can check here. At 4 is going to be 2. We have the number 2 here. At 16 is going to be, so you see these 2 points is going to be enough to graph the basic function, which is like this. So now let's check the first technique. Is shifted down. So if you check this graph, here is the basic function is shifted down. Check the original point, shifted down until this point, which is -8. That means the new graph is going to be shift down. I'm gonna -8. Here is the X. Then it's shifted to the left. How many units? 2 units to the left. So it's going to be 2 units to the left, so add 2. So our new function is going to be, X square root, square root of X plus 2. And outside, be careful, -8. Not here. I can't copy. I have to rewrite this one again. Here. So it's going to be X plus 2 and outside -8. Let's check the second one. The second one is really important because we have more than one technique. So the graph of the basic function here, like this. The first thing, check the graph is look like on the opposite side. It's totally different direction. That means it's if you reflect it over x-axis, it's going to be like here. That means it's okay. I'm gonna reflect over x-axis. So the new function, here's the x squared, the square root of x. I'm gonna reflect it over x-axis. Then what I'm going to do, the second technique, I'm gonna reflect the new graph, which is this one, over y-axis. So I'm gonna reflect this one over y-axis. Now we have exactly the same graph. That means we have two reflections over x-axis and over y-axis. So be careful here. What I'm going to do here now, here is the other reflection, parentheses, here is x. So you have to put parentheses and put the reflection over, here is the reflection over y-axis, and put parentheses x, because we have two techniques here inside. So I have to separate these two techniques. Here is the reflection over the x, and let's write down the second technique. Then the second technique, next technique, so let's erase these two. And because here is the new parent function with these two techniques, the negative reflection over x, reflection over y. Then it's shifted to the right. How many units? This is 2, that's meaning 3. Shifted to the right 3 units. So the origin point is going to be, that's mean our new graph is going to be here. Start from this point and keep going like this. That's mean we're gonna say -3, close the parentheses. Then shift it down, how many units? Also 3 units, so -3 outside. So you can write down like this, 100% is going to be right, or you can write it down as distribute the negative sign, -x plus 3 -3. Supposed to be both. When you enter your solution, is going to be right. So let's write down, it's a square root, negative square root. And I'm going to type -x plus 3. And outside, I'm going to say -3. So submit, and that's it for this example. Now our new graph, and we have to write down, first of all, the parent function. This is the graph of the parent function for x cubed. So we're going to type just x cubed. Now, let's check what happened to the graph. The graph is shifted to the right. So it's horizontal shift to the right. How many units? Because here is the basic function, the original point, and it's shifted 5 units. So it's horizontal shift 5 units to the right. That means you're going to type here a new function, which is x, not x because it's horizontal shift to the right. So I'm going to open two parentheses and I'm going to say x to the right. That's mean -5. And don't forget the cube. It's a cubed. That's it for this one. Do we have to submit. That's it for this example. Let's check the next one. The next example, it's really important, the next example, and let's check what happened. So next example, you have this line. This line is similar to the identity function, which is f of x equal x. But when you graph the identity function, that's why they called it identity function. Let's graph it. The domain for the identity function is from negative infinity to positive infinity. So when you graph this basic function, x, y, if you put -4, y is going to be -4. 0, y is going to be 0. 4, y is going to be 4. Because you're going to plug in the number here, and it's going to be exactly the same thing. That's mean -4, -4, 0, 0, and 4, 4. So when you graph these points, let's check how it's going to be the graph. If you graph the basic function, here is the point 0, 0. The other point is -4, -4. That means here. And 4, 4 is going to be here. So the basic function, the graph of the basic function, it's hard to graph a line here. It's going to be like this. Almost like this. It's supposed to be a line. Let's try to fix the other side. To the point 4, 4. It's supposed to be a line. So here is the graph of the basic function. What happened to the graph? If you look here, the graph it's moved down from this side and moved up from this side. That's mean you're pressing on the graph here and you're pressing on the graph here. That's mean here is the graph of the basic function. You shrink the graph. You're pressing on the graph from both sides, from here and from here. So it's a vertical shrink. So now, first of all, when I need to write down my basic function is just x. Then I already know it's a vertical shrink. Here's the vertical shrink. Then I need to write down my new function. So how am I going to check it's a vertical shrink? That's the important thing. Let's delete all these. How I'm going to check it's a vertical shrink? So what I'm going to do, the easiest way, pick 2 points from the line. I'm going to pick this point, and I'm going to pick this point. Let's write down the coordinate for this point. Pick 2 points, this one and this one. Any 2 points from the graph. You're not going to choose a decimal number. So the first point is 0, 0, and the second point is 2, 2. Here is the first point, and here is the second point. Yes, 2, 1. 2, 1. Because 2, 2 exists here on the basic function. So let's find the slope for this one. x1, y1, x2, y2. That means our slope is going to be y2 minus y1 over x2 minus x1, which is going to be y2, 1, y1 is 0 over x2 is 2, x1, 0, that's mean half. That's mean the value, this one is going to be multiply the basic function. So our new function is going to be 1 over 2, because it's a shrink, that's mean outside 1 over 2x. 1 over 2. If you go back here, when it's a vertical shrink, 1 over the number. So 1 over 2 times x times the basic function. That's why it's a vertical shrink. 1 over 2 times x. So what I'm going to write down here, I'm going to just say 1 over 2. So it's a shrink by 2, not by 1 over 2. You're going to say it's a shrink by 2. So this one, shrink by 2. Vertical shrink. You can check because we have vertical shrink and horizontal shrink. So that's it for this example. So every time when they ask you, you already know it's a shrink. How are you going to find it's a vertical shrink, like shrink by which number? Just go ahead, find the slope. So when you need to find the slope, write down the slope because it's a vertical shrink outside. That's why it's a shrink by A. Let's check next example. So here is the next example. We're going to check that. The parent function is the absolute value of x. You're going to go to the functions, and here's the x. That's it. And let's check what happened to the graph. The graph, the basic function here is shifted to the left 4 units. That's mean vertical shift. No, it's horizontal shift 4 units to the right, horizontal shift 4 units to the left. That's mean the new graph is going to be, here is the functions, choose the absolute, and it's going to be x to the left, so it's going to be plus 4. That's it for this example. Let's go to the next one. Let's check next example. The function g is related to the parent function. Describe in the area section g of x squared plus 6. What's the at the end of the parent function? The parent function on this one is going to be just x squared. And describe the sequence transformation. Which transformation happened to this graph? It just shifted up, vertical shift 6 units upward. The new graph is going to be shift 6 units up. That's the only graph is shifted up because this one reflect. This one is shifted to the left. This one down. This one, the only one shifted up 6 units. So you're going to choose this graph. When they ask you, use the function notation to write down g in terms of x. So how are we going to type this one? This is really important. Do not do mistakes here. That means the basic function, we're going to type the basic function f of x. That means you're going to type here just the x. So g of x is going to be the parent function, which is f to the x, shift up, so you're going to add 6. So it's going to be 6 plus f of x. Okay, so f to the x, that means you're just going to plug in f of x, you're going to add the 6, which doesn't matter. It's still the basic function, and 6 is referred, that means shift up. Next one, we get the shape of f of x equal x squared, but shifted 2 units to the left. So you're going to shift 2 units to the left. That's mean f of x equal. Shift 2 units to the, shift 2 units to the left. So it's going to be x plus 2 units to the left because it's inside technique. Then shift 4 units up. That means I'm going to add 4 units up and reflected in x-axis. Reflect over x-axis, that means negative sign outside the function. So here No, sorry, here is going to be negative, 2 parentheses, is going to be x plus 2, and do not forget the squared, and here is going to be plus 4. That's it for this example. Next one, you can check that before we move into the next example. Next example, let's check what's happening. Shift 4 units up and reflected in x-axis. Shift 2 units to the left. In fact, there is a wrong thing with this example. The question I contact Cengage and they have to fix it, but this is the right solution for this one. I need to check and I'm gonna let you know. Let's go to the next one. This example, we're gonna use exactly the same function and shifted 5 units to the right. That means let's put x 5 units to the right minus 5, and it's going to be squared. So here is the square, and 5 units to the right and 9 units down. So it's going to be minus 9. 5 units minus down. So this one is going to be wrong. Sorry, right, but the previous one is supposed to be right. So this is right also. Let's check the next one. Now x cubed was shifted 18 units to the right. 18 units to the right. So it's x cubed now. So here is x. Now shift 18 units to the right. So it's going to be minus 18. Do not forget the cubed. Sometimes you forgot the cubed and you're going to send me text. Next example is going to be shift 5 units to the left. X cubed. So I'm going to put 2 parentheses x 5 units to the left. So it's going to be plus 5. And I'm not going to forget the cube. But 7 units down, so it's going to be outside minus 7 units down, and reflect over y-axis. Reflect over y-axis. I can take this one. Y-axis, so I'm just going to put the negative sign here. Y-axis. Next example is going to be now the absolute value shifted 15 units. The absolute value, go to the functions. Here's the absolute value, 15 units up. Here's the x. The 15 units up is outside. And reflect over x-axis, that means the negative sign outside. That's it for this example. Next one, it says 15 units up and reflected in x-axis. Yeah, that's right. So I need to contact them also about this example. Let's go to the next one. Shifted 3 units to the left. So here is the absolute value. Shifted, here's the absolute value, shifted 3 units to the left. That means inside to the left is going to be plus 3. And 6 units down is going to be outside. 6 units down, so minus 6. Let's check that. So 2 questions. I'm going to check the company. This is right. Now, next example, which is the last one. Then we're going to go back to do 1 more examples. Consider the following, and the parent function for this one is x cubed. Here is the x, and here is the cube. Now, let's check what happened to the graph. Before I'm starting, let's check, is that really the graph of x cubed, or it's a new graph by doing some transformation on it? So what I'm going to do, the graph of the basic function is x cubed. The domain is negative infinity to positive infinity. So I'm gonna do a simple graph, x, y. I can choose any negative number and positive number. Let's choose -2, 0, and 2. -2, plug in -2 here is going to be -8. 0 is going to be 0. 2 is going to be 8. That means we have -2, -8. And the second point is 0, 0. And the third point, 2, 8. Let's graph these points on the same graph and check if there's a technique adding on this graph. So the first point is -2, -8. That's mean -2, here's -2, and -8 is not on the graph. It's here. -2, this is -10, -10, this is -10, this is -8. Here is this point. That's mean this side from 0, 0, the graph going down here. I'm graphing the basic function. 0, 0, here's the point 0, 0. 2, 8. So here's 2, and here's 9, here's 8. That means this side is going up to the 9. Okay. So here is our basic function x cubed. So as I told you, if you look to the parent function, the basic function x cubed, and the new graph, that's mean it look like there's, you pressed on the graph from this side to move it here, and you pressed on the graph from this side. That's mean you're pressing on the graph from both sides, or you're pressing on the graph from the top, pressing on the graph from the bottom. So if you press on this one, you're gonna shift it here. If you press on the graph here, you're gonna shift it here. So let's do the vertical. You pressed on the graph from top and the bottom. That means you shifted. You shifted vertical shrink. You're going to do a vertical shrink. Yeah, a vertical shrink, or you're going to do vertical. No, no, sorry. It's you're not pressing on the graph from the top, because you pull on the graph from the top. So you pulled this graph from the top here, so it's gonna shift it here, and you pull on the graph from here, it's shifted to the new location, to here. That means it's a vertical stretch. You pull on the graph from both sides, from here and from here. So to find that, pick 2 points from the graph. Let's choose this point and choose this point. This one and this one. That's mean I'm going to say the first point is 0, 0. You can choose any points from the graph, but I'm choosing this point because it's easier to graph it. The second one is 1 and 3. So 1, 3. x1, y1, x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1, which is going to be y2 is 3 minus y1 is 0 over x2 is 1 minus x1 is 0. So it's going to be 3 over 1, which is equal to 3. That means the graph is stretched by 3. So how I'm going to say it's stretched by 3? You're going to say 3 x cubed. That means our new function is going to be 3x cubed. 3x, and here is the cubed. That's it for this example. Let's go back to example 4, because 4, 5, 6, 7 is going to be the same way, just different shapes. So example 4, let's check. Here is the basic graph. Now we have this graph, and we have to find if the new graph, if you have y equal fx minus 4, that's mean minus 4 inside the basic function, so it's going to be shifted to the right. So which graph is shifted to the right? Check this point, pick any point, and check if it's shifted to the right. So if you pick this point, shift it to the right, so that means it's going to be 4 units. So it's going to be 1, 2, 3, 4. It's supposed to be here. That's mean not this one, not this one, of course not this one, this point or this one. This one moves here. It's supposed to be 4 units. So 1, 2, 3, 4. It's going to be here, which is this one. So this is the right graph. That's mean I'm going to choose this one. On this one, I have to go down a little bit here. This is the right one. Let's go to the next one. I can't check it. Let's go to the next one. The same thing with the same graph. This graph, we're gonna do the same thing. But what we're gonna do, we're gonna do the second option, negative f of x plus 4. That's mean you have to reflect over x-axis and shift it up. So you're gonna reflect this graph over x-axis and shift it up. So let's check here. Which graph is reflected to the x-axis and shift up how many units? 4 units. Yes, 4 units. So let's check. So this is reflect, this is reflect, also this one, and also this one. But this is shifted down, this is shifted left, this is shifted right, this is shifted up. So we're gonna choose here. I have to choose this one. How are you gonna check that? Let's go back to the original graph. So if you reflect this one over x-axis, that's mean this point is going to be 0, -5. Going to be here. Then shifted up 4 units, 1, 2, 3, 4. So here is going to be here. That means the graph is going to be like this and like this on this side. So the point is going to be just on 1. Let's go down. That's why we choose this one. Now 1 over 2 f of x. So the graph is going to be, if it's 1 over 2, that means shrink by a. It's a vertical shrink. You're gonna press on the graph from both sides, and you check this is not a shrink, this is a vertical shrink. That's what we're looking for, vertical shrink. You're gonna press on the graph from the top and the bottom. It's a vertical shrink. So this is not a vertical shrink, it's a vertical stretch. This is reflect, reflect, so you're gonna choose this one. Next one is going to be reflect over y-axis, x-axis, but it's going to be shift to the left. So all this graph, it's reflect over x-axis, but which one is shifted to the left? This is to the right, this is down, this is up, this is the only graph shift to the left. And the next one, f of x is negative x, it just reflect over y-axis. Here is the important thing. So if you reflect the basic function, which is this one, over y-axis, That means this side is going to be goes here, and this side going to be here. So it's going to be exactly the same graph. That's why you have to be careful on this one. So you're going to choose exactly the same graph, which is this one. Careful, this is the 0.05. This is less than 0.5. So I'm not going to choose this one. I'm going to choose this is the right one. Now the basic function shifted down, not this one, not this one. This is up, this is down. Now the basic function is 1/2 inside the basic function. That means it's a horizontal stretch. If it's 1/a inside the basic function, it's a horizontal stretch. That means we're going to do a horizontal stretch. Which one is going to be? That means you hold the graph from both sides and stretch horizontally. From both sides and stretch horizontally. So it's going to be wider. The graph is going to be wider. So I can't choose this one. I'm not going to choose this one. This is the only graph is wider because you hold the graph from both sides and stretch horizontally. So it's going to be this one. I think that's it. That's it. This is a high. So you can do example 3, 5, 6, exactly the same way to solve this example. That's it for today.